Hello children, today I will be telling you about pressure in fluids and atmospheric pressure. So before we talk about pressure, I want to tell you about what force is. As you know, in your earlier classes, you've studied what force does. Force is a push or pull movement, stretch or squeeze movement. And what does this force do? What are the effects of force that you have studied? That is, force can start a stationary object, can stop a moving object, change direction, change velocity, and also change the dimensions. So when force acts upon a body, it causes some kind of change. Let's talk about a particular kind of force. That particular kind of force, when acting perpendicular to the surface or normal to the surface, is known as thrust. That is, if you take a body and you apply force on it in the perpendicular direction or normal to it, then that force is known as thrust. Then if we talk about weight, the weight of a body. Now weight of a body is also the force of gravity which the earth is applying to pull the body downwards in a particular direction. Again, that is perpendicular also. Therefore, weight can also be called as thrust. Therefore, thrust or force in a particular direction, that is perpendicular, or weight mean the same. So let's now talk about units of thrust. Now, as thrust is a particular force, therefore the SI unit of thrust is Newton and CGS unit is dyne. The relation between them is 1 Newton is equal to 10 raised to the power of 5 dyne. There are other units also of force of thrust, that are the gravitational units when gravity plays an important role. Those units are kgf and gf. The relation between them in terms of Newton and dyne are 1 kgf is equal to 9.8 Newton and 1 gf is equal to 980 dynes. So this was all about thrust. Now thrust acts on a surface, means it depends on the surface on what it is acting. Now if thrust is acting upon a body in all directions, then the total sum of the thrust that is being applied with respect to the area will now be termed as pressure applied. Now let's talk about pressure. Pressure is thrust acting normally on a body upon a particular surface area or the surface in contact. Therefore, the formula of pressure is thrust upon area. Thrust, as you know, is a force and area is a contact surface that we are talking about. So when we talk about the unit of pressure, the unit of pressure over here, there are a lot in number, right? We talk about fluid pressure, we talk about pressure applied by solids, then the atmosphere is also applying a lot of pressure. So therefore, all these terms can be put under different kinds of pressure units. So let's discuss them. The first one, if we say pressure, taking the formula first, thrust upon area. So when we talk about the unit of pressure, we will first talk about unit of thrust divided by unit of area. Now unit of thrust is Newton and unit of area is meter square. So it can be framed as Newton per meter square, right? It can also be given as Pascal. It is after the French scientist Blaise Pascal who invented this, who discovered this. Therefore, 1 Pascal is equal to 1 Newton per meter square. Then the other units are, the CGS unit is dyne per centimeter square. Other units, when gravity plays an important role, thrust in terms of gravitational unit. Then pressure can be given as gf per centimeter square. Then there are other units also that you will be studying in your higher classes, that is mar and millibar. That is 1 bar is equal to 1000 millibar and 1 bar is actually equal to 10 raised to the power of 5 Newton per meter square. Then there are further units also given. Now let's talk about atmospheric pressure. 1 atmosphere is also a unit that is used for pressure. is equal to 0.76 meters of mercury. Now you've heard about a barometer. The barometer is used to measure the atmospheric pressure. So when atmospheric pressure is measured by a barometer, the normal atmospheric pressure is given by 0.76 meters of mercury column, right? That is equal to 1 atmosphere. And in terms of Pascal, when we talk, it is 1.013 into 10 raised to the power of 5 Pascals. Then the other units are torr. 1 torr is equivalent to 1 mm of mercury, and 1 atm, that is 1 atmosphere, is equal to 760 torr. So there are so many units of pressure that we have learned today. First one is Pascal, then it can be Newton per meter square, then dyne per centimeter square, GF per centimeter square, bar, millibar, atmosphere in terms of mercury column, and torr. So all these units are very important for you to know. Now let's talk about pressure in detail. What does pressure depend upon? Pressure depends upon two main factors. First one is magnitude of thrust, and the second one is area on which thrust is being applied. Now if you see the formula of pressure over here, pressure is directly proportional to the thrust, but it is inversely proportional to the area. That means if thrust increases, pressure increases. If thrust decreases, the pressure also decreases. The opposite is for area. When area increases, the pressure decreases, and when the area decreases, the pressure increases. Means pressure and area are inversely proportional to each other. So pressure applied on a surface depends on two main factors. That is, first one is magnitude of thrust, and second one is the area on which the thrust is acting. Therefore, in order to increase or decrease pressure, we can either increase the thrust in order to increase pressure, or we can decrease the thrust on the surface in order to decrease pressure. Now, if we want to have thrust to be constant, in order to increase pressure, if we decrease the amount of surface area of a substance, we will be applying more pressure on it. For example, a thumbnail. If you have been using it in school a lot, the thumb pins. One side is pointed and the other side is blunt. Therefore, from the blunt side, if we apply pressure, the pointed area has very less area of contact, due to which pressure applied will be more. Therefore, whenever we want to apply more pressure, we can make the area to be less. Another example I will give you about the cutting tools. Whether we talk about scissors or knives, we always have one side to be very, very sharp. In actually doing what when you are making it sharp? We are decreasing the area. So when area decreases, it becomes sharp and pointed. We are applying more pressure through it. Therefore, there are some times when pressure is too much to be handled and you have to decrease it. The thrust cannot be changed. Therefore, area can be increased. As we have done examples in our lower classes, like tanks, the war tanks, they have caterpillar wheels, so that the base area increases and less pressure is applied on the ground. Your trucks and trolleys, instead of having 4 wheels, they have either 6 to 8 wheels, so that area is distributed over a large portion. So the pressure applied, the weight applied by that truck on the ground is less. Therefore, we can conclude, in order to increase or decrease pressure, we can either increase the area or we can decrease the area. So now, let's start with pressure in fluids. First of all, the difference between pressure applied in fluids and pressure applied in solids is that when pressure is applied on a solid, that is, if we take a solid, pressure applied by this solid will only be at its base, that is the weight that acts downwards, right? So, the pressure applied by any object or solid, to be precise, will always be in the downward direction, that is the weight. And when we talk about liquid pressure, now pressure will be applied on the base because of the weight of the liquid, but also pressure will be applied on the sides of the container also. Therefore, in liquid pressure, pressure is applied in actually all the directions. For this, I will give you an example. This is a setup, an experiment done in which in a container a liquid was taken. Generally we take water. In this we made a hole over here. On making a hole over here, we could see water spilling out. On making another hole near the middle, water spilled out to a larger distance. And on making a hole near the base, near the bottom, the water was seen to flow or to have a velocity higher than the above two liquid flows. Therefore, it was seen as the layers of water were becoming more and more, was becoming deeper and deeper, the pressure applied was more and more, which could be seen in the different velocities of the liquid. The velocity of this liquid coming out is more than the previous ones. This showed as you keep going down, the layers of water keep on increasing. Here very less liquid is here, therefore weight will be less. As you keep coming down, the layers of water keep on increasing, therefore the weight of the liquid keeps on increasing, due to which the pressure applied will not only be there at the base, but it also will be there at the sides of the container. Now, if we take a stone or we take an empty mug, if you've taken an example in which when you are taking out water from a bucket with the help of a mug, when you immerse this mug over here, what happens is this liquid from here rises upwards, and when you further send it down, liquid over here rises further. On making a small hole inside this, the water gushes out from the downward direction towards the upward direction. So, this experiment shows that liquid pressure not only applied at the base, but it also applied at the sides as well as the top of the container. Therefore, difference between solid pressure and liquid pressure, liquid or fluid. When we talk about fluid, we are talking about liquids and gases. Solid pressure will be applied only on the base of it, whereas liquid pressure will be applied in all the directions. To study about it in detail, we will talk about pressure exerted by a liquid column. If you see, this is a container, a vessel in which a solid has been placed, and this solid has been immersed in water. We are taking this liquid, we take it as any liquid or we can take it as water, and it is immersed up to a height h. Let the density of the liquid be d and mass of this body is taken as m and g being the gravity. So, let us calculate the pressure exerted by this liquid on that object. In order to know that, we will be using the formula for pressure, that is pressure is equal to thrust upon area, right? Or instead of thrust, we can also write weight upon area. So, pressure becomes equal to mass into gravity. Why? Because mass into gravity is equal to the weight divided by the area, right. So, I am writing this in short form. P is equal to m into g divided by A. In the previous chapter, we studied about density. Now, density formula, if you all remember, density is equal to mass upon volume. So, if we change this formula in terms of mass, it becomes equal to density into volume. So, we will be using this formula in the given equation. Therefore, P becomes equal to, instead of m, we will be writing d, that is for the density of water, into V into G divided by area. So, I have substituted the value of m in place of d and v, right. Now, let us talk about volume. Volume of an object is usually written as length into breadth into height. Instead of length into breadth, if we use the formula of area, so volume will be written as area into the height. So, let us use this formula of volume in the given equation. So, instead of V, we are going to put A and H. So, now what happens to this equation? Let us see what form it takes. P is equal to D into A into H into G whole divided by A. Now, if A is in the numerator and denominator, we can cancel it, and P gets the form of D into H into G. We can reframe it is equal to height into density and into gravity. So, this is what liquid pressure is equivalent to, HdG, or you can write it as D into H into G. So, this is the form of liquid pressure. Now, if P naught is taken as the atmospheric pressure, therefore, the total pressure acting on the body will be the atmospheric pressure plus the pressure that we have just calculated. That is P naught for atmospheric pressure plus HdG. So, this is what atmospheric pressure is. Therefore, if we take gravity to be constant, we can say pressure depends upon density of a liquid and height or depth of the liquid. That means if we go deeper down inside, if height increases, the pressure applied will also increase. That is the first law of liquid pressure, that with increase in height, the pressure in the liquid increases. Now, at the same place, at the same part, if we apply or measure pressure at every part on this plane, pressure will be the same. So, pressure in a plane will always be same. Now, when we take different liquids, if we take water, if we take oil, means we are actually changing the density of the liquid, right. So, even when density changes, the pressure also changes. Both of them are directly proportional. So, more the density of the liquid, more is going to be the pressure applied. Then pressure, when you talk about pressure at the given points in a liquid, if we take any point in a liquid, pressure felt by this point will be exactly equal from all directions. And the last law of liquid pressure will be that pressure is applying on a liquid, therefore it seeks its level. So, whatever level a liquid is at its highest point, it always seeks its highest point, it always seeks its highest level. So, there are certain properties or certain applications that you will always see in your daily life when you deal with liquid pressure or fluid pressure. That is, if you have noticed, the dams, they have walls in little triangular form, that is, the bases are broad and the top portion is tapering. That means the broad portion is because pressure increases with depth. So, as you go deeper down inside, more and more water will be stored, therefore more pressure will be felt, therefore the walls are made stronger and broader at the base. Then another example will be the deep sea divers. If you notice, they all wear specially designed suits. They have special suits that they are wearing, because of which they can withstand that huge pressure that they will feel when they go deep inside the ocean or the sea. Then the size of a water bubble inside the liquid, as it keeps on rising, if you see, the size of the water bubble keeps on increasing. Why? Because as it keeps on coming up, the pressure becomes lesser and lesser. As it was going down, it would feel more pressure. So, the reverse of it is, as it is going higher, the pressure will decrease. Therefore, if less pressure is applied on that bubble, it will keep on increasing in size. So, these were the consequences and the applications of liquid pressure that you will experience in your everyday life. These are the basic examples. So, thank you children for this, and I hope this video helped you to an understanding what fluid pressure and atmospheric pressure is.